Okay, here's what I'm thinking on what I'll affectionately refer to as the space door. Basically, I should start with the internet here. I purchased because I couldn't find. Yeah, so I purchased this. There it is. Um, I don't know. I just really wanted to have it in my possession. I think it was because when I called the company, it was hard for me to find out exactly how much force it takes to move that rod. I know I'm going to have to do something automatic. So I took that drawing and then uh, made a sketch of it. Let me turn this threshold off so we can see the bottom. And you can see if I zoom in here, that's the drawing they present you with on the website, scaled up. I'll turn that threshold back on. So that's coming so that I could figure out how to make it fully automatic. The next thing it took me a while to find was a continuous duty push pull solenoid. So this is a 12 volt continuous duty push pull solenoid. I got that coming as well. And then um, I'm going to try to hide that down inside the cavity. There's going to be some room between this aluminum frame that I'll create. That's the 1/2 inch drywall here, which we said on the inside is like inch and what do we say? Inch and a half with all the padding and everything. But anyway, you get the idea. I modeled all the wood that's already there and everything, so I know the thicknesses. The inside door frame actually ends up being a little bit thinner than the outside door frame, but you get the idea. But it leaves me, there's a pocket inside of there that I think I can hide that solenoid to actuate this door seal. And then the door seal, when you open the door, the door seal will exist in the door frame. Does that make sense? I'll have door seals on all the sides opposing one another with actuators. You can say I removed that bottom one, but I'll have actuators that actuate each one of these door seals. So when the door slides into place and closes and hits a button that says that it's closed, I'll send a 12-volt signal, and the entire perimeter of the door will be pinched with that rubber seal. As far as the threshold, and I accidentally moved it here a minute ago, I don't think we need to. I don't think we need to put a groove in the bottom of the door. Um, there is enough guidance here on this door, on the system that you've already got. With this, there'll be 2 points here that it's touching, and then the whole track on the top. There's no reason for us to need a groove in the floor, and with us putting another one of those automatic seals in the bottom of the door, when you close the door, it's just going to automatically seal against this threshold. So I think the threshold is going to be, and since I already kind of ruined it, I'll move it out of place. I think it's a relatively simple piece that we can laser cut and fold. And then you see this lip here, which will be, like a trip hazard. But I think the easiest way for me to eliminate that lip is to do that with concrete on this aluminum piece. Like I will embed screws in the aluminum and then use concrete to make sort of a dome shaped transition piece. And I got it coming out here 2 feet. It's like 4 feet wide and 2 feet sticking out in front here, and I can really make a gentle, non-trip hazard entryway that covers up that carpet and transitions us to the outside world. So that's my plan. There was a combination of aluminum and concrete. Um, yeah, I think that's it. The door frame would have the seals embedded in the door frame. I want to make that out of aluminum. I want to use a lot of there's a 3M 2-part epoxy that's good enough to roll a car down the hill, and that they advertise you can. And I've used it on a couple of projects. As long as your excuse me, as long as your seams are overlapping enough, then the shear force of this glue is comparable to a weld. So I think I can make this door frame without any welding to keep the cost down. Um, and it would just be angle iron. I'm not even going to form it. I'm just going to use, I say angle iron affectionately. It's angle aluminum. It's an extrusion. That brings up something else I wanted to talk about. It's fairly expensive. 25 feet of it is $700. It's going to take about 2 sticks. So you're looking at $1,500 in just aluminum just to frame the door. But that gets us, but here's some ballpark of prices. We haven't talked money yet, but yeah, there's, if I'll probably need several of these actuators. Let's see, that was the seal. I plan on buying 2, 4, 6, 8 of those. That's for one door. No, it's 10 for one door. So it's $1,800 for a door. And then I would need 2 doors. So you're talking $3,600 worth of those. And then, where was it at? This piece is another $160. I just paid $180 with shipping. So, and then you might need, I might get away with one of those and a bunch of cables, or I might have to do like maybe one per side. I don't know. You're going to end up with another, I could see it as much as another $1,000 in solenoids. So I wanted to talk about cost with you guys as well as we're looking at this stuff. Um, but I do think that'd be a good way for a door. Oh, the other thing I wanted to talk about was the inside of the door. I would just leave it wood. I think I would just paint the wood. The door would go up against the wood. If that's a problem, I have to make some sort of aluminum liner for it to go down inside of. Obviously, on this side, the door will always be there, so I don't really have to think about it too much. Um, but on the other side, I just kind of have it modeled as being wood. And like I said, since we're pinching on the both faces of the door, you can just paint that black and leave it alone. While I'm talking about this model, let's talk about the wave ceiling. My hesitance on the wave ceiling, let me think here, is that it's so thin in some places. I really don't like how much wave I got out of it. I made it visually what I wanted it to be, and then it kind of gets up into the rafters where I shouldn't be. So then I made some bumps because it's just foam, so we can kind of do whatever we want. Anyway, now I'm thinking about asking you guys if I could just do strips. Like, what if I did aluminum strips um, that were maybe an inch wide or something, and I just made a bunch of wavy aluminum strips that got us the same effect. I wonder if that would be okay. It's not going to be as good for sound, obviously, as the felt idea. So if we're gonna do felt, then I gotta spend some more time on um, how I'm gonna get this to look right. And I really did not want to go up above these. These represent those rails that hold the ceiling up on the building. So that's what I was going to clamp to. And I'm right up against the edge of them there, and it's kind of thin. And I don't know. I can talk more about that some other time. But let me know if I'm headed the right direction on the door. And then I think I'm ready for you guys to tell the drywaller to drywall up as far as he's going to drywall to the edge. And then I'm going to take up the rest of the slack with aluminum. And I don't feel like this is the kind of project I'm going to build at the shop and then install. I think I'm going to treat it like I was a carpenter and just come there with a bunch of aluminum and my I always cut aluminum on my miter saw. Just change the blade to a real fine tooth. So I think it's just something I'm going to literally build on site. I might even paint it on site. Um, that's what I'm thinking. So again, let's talk about that when we get a chance. Thank you guys.